Good day. Welcome back to Mike's Radio Repair and Restoration. Today we're going to tackle a frustrating subject for many newcomers to the hobby, troubleshooting your tube radio if your tube radio should not work. First off, let's begin with a statement that in these old tube radios, there's high voltage present. It's often lethal high voltage. If you make a mistake, things could go badly wrong and you could get hurt or much worse. So if you follow along, you do so at your own risk. So this particular troubleshooting step by step, is targeted towards a tube radio which has been restored already by you or by someone else and does not operate. This does not apply to a tube radio that has not been restored, that's got the old wax paper capacitors or not had the filter caps replaced. You have to get that done along with the resistor basic check, wax paper capacitors replaced and electrolytes replaced before you can move on. This is, you've restored radio and it doesn't fly, or somebody else has restored radio and it's not flying. That's what this is targeted to. So with that in hand, so I'm going to break this up in steps, like the same way I have 5 steps for restoring a radio, I'm going to have steps for troubleshooting it. It's going to make it, if you've got some very basic test equipment like I'm going to go through here with you on the bench, it's going to make it real easy to narrow the problem down very quickly and get to the heart of the matter. So this is the equipment here that we're going to be using to troubleshoot. And I'm just going to go through it with you here one at a time. I have my RCL meter here, which is mostly going to be used for resistance. I have my trusty Series 5 Simpsons 260, which is going to be used for measuring DC high voltage. I have a Heathkit IT12 signal tracer, and it has the probe that's got the switchable RF and audio on it. An IT4 or any one of the Heathkit signal tracers. Back here I've got an old ICO. I haven't restored this yet. I just picked this up for 25 bucks. I'm going to restore it and build a probe for it. So if you can lock on to something like this, that would be great. So any one of the Heathkit signal tracers or the ICO signal tracers is really critical. Now, if you don't have these and you have a scope that, you've got an input voltage of more than 300 or 400 volts, you can actually use a scope and you can monitor gain per stage, but we won't worry about that. But just on the very basic level, a signal tracer is really needed. And the last thing is our basic function generator, which we use as a signal generator. So these are the basic tools we're going to need. The signal tracer is really very key, as is the generator and the meter. So let's head into a schematic and start talking about the first step. So step 1 of troubleshooting. High voltage, which is also known as B+, and filament voltage, and a few other checks here. Let's go through some basic steps here now. I've thrown in check AVC switch and RF gain control because I've had a few radios over the time where the AVC switch was open, rendering the radio dead, or the RF gain control had lost its ground, or somebody was mucking around with the control and the ground to all the cathodes of the RF tubes disappeared. So it's a good idea to just quickly check those 2 switches and controls and make sure they're okay. Another thing to check is it dead on one band only? That kind of sort of very narrows things down immediately to your oscillator stage, most likely. But it could be a couple things. So we're assuming at this point that the radio is just plain old dead. But if it's dead on one band, that narrows your focus down. So getting into step 1, do we have 120 volts AC to the power transformer? So that's checking the switch, the fuse. Does the radio light up? Do you have filament power? And there's usually at least in a lot of these sets, 2 filament powers being 6.3 for most of the tubes and 5 volts for the rectifier. Your mileage may vary depending upon what set you're working on, so we're going to check that. And at the end of the day, we want to make sure we have high voltage DC, which is B+. So let's just look at a couple of schematics here. And this here I'm circling is the RF gain controller, often called sensitivity. I've had a few radios where this ground was mucked with, and then none of the cathodes had a ground, and the tubes weren't functioning. So the radio appeared dead, and just repairing the ground to that control solved the problem. Now moving on to the power supply. Of course, we want to make sure that our switch is working, and if there's a fuse, we want to make sure the transformer is getting power. We want to make sure that we have high voltage on this pin on the tube here. So I mean, if we've got power to the transformer, we usually have dial lights. We can check our 6.3 volt filament voltage by looking at usually the audio tube is usually a glow. If the audio tube is a glow and you can see through the glass, and you've got dial lights, because here's dial lights are also on 6.3, you're probably good to go with your 6.3 volt filament voltage. If your rectifier tube is an 80 or a 5Y3 or some such, it'll be glass. Is it glowing? Is it glowing? If it's glowing, then you've got the 5 volt filament voltage, and the last thing you'll need to check is the output of your rectifier tube to make sure that you've got high voltage DC. And if you notice, this is marked as V9, so if I come over here V9, I can see that my inputs from the transformer are 325 volts AC, and my output is 350 volts DC. So that's what we want to check. Now, if you remember, also why we're navigating around the bottom of a tube radio, and I'm saying the bottom is looking at the chassis, that these octal tubes are keyed, and there's, if you see my mouse pointer, there's a little pin. If you look at the pin, you can count, or the notch, or the locating pin, the pin of the tubes move clockwise, 1, 2, 3, 4, 5, and so on. So that's how you navigate under the chassis. There's a dot here on the bottom of this one here, but mostly you'll have to go by wiring depending upon the type of tube socket you've got. There'll be 2 small pins and 2 big pins to take a peek at. So that's a pretty quick thing. You can go through a lot of this very quickly. The ABC switch, the RF gain control, you can go through it with an ohms meter or a continuity meter. It's a dead on one band only. You need to get that question answered. Most of the time the whole radio is dead. 120 volts to the power transformer. Check that out if you've got power. Do you have filament voltage? Do you have panel lights? Are your tubes glowing? Is your audio tube glowing? Is your rectifier tube glowing? Also, if your radio is full of metal can tubes, if you've left it on for a couple of minutes, all the metal cans should begin to get warm. It's good to check them all, because every once in a while I'll get one of those old metal can tubes that'll have an absolute filament failure and be open, and it'll be cold. So you make sure that all your metal can tubes are warm, and then check high voltage DC. So let's put some of this to the practice. I just finished restoring an S40, and the S40 is going to be a good candidate to learn with. So let's go to the bench and check a few of these things. Okay, so I have already confirmed that my ABC switch has got continuity, and that my sensitivity control has got a good ground. So those steps are dealt with. We have dial lights. We have 6.3 filament voltage. We have our 6F6 audio tube is aglow. Our metal can tubes are warm. Our 80 rectifier tube is glowing. So I know that I have my 5 volt filament. I know I have 6.3 filament. So the last thing that I need to look at in phase 1 is, do I have correct amount of B plus or DC? So I'm going to check that now. Now your voltage is going to differ these radios were made for like 115, 117 volt wall power. You may have 120 or more. So you may get a 10 or 15 volts higher than what you're expecting, than what the schematic says. The schematic's looking for 360. I've got my Variac set on 118, 117, 118 volts there. So I'm hoping to see around what the manufacturer wants now. So let's have a look here, see? And again, this is high voltage, is very dangerous. And I'm just about bang on 360 volts DC B+. So I know that my B+ is okay. So we've kind of sort of confirmed some basic things, that we've got power to the transformer, we've got both filaments, and we've got B+. We've also concerned that there's nothing funny going on with a couple of the switches on the front. So at this point now, it's time to move on to step 2. Step 2 is making sure the oscillator, the VFO, is running. This is the big test for this step. It's simple to do. We have to determine the injection frequency, if it's high side or low side, and what the IF frequency is. Now, if you don't understand this, I have another video on my channel called Basic Receiver Theory that you should watch and understand how to determine what the injection point is. What we're going to have to do is calculate, with this particular radio we're using, the first 3 bands are high side injection, and the IF is 455 kilohertz. So that means that the VFO is going to be running 455 kilohertz above the desired tuned frequency. So when I tune the VFO around 10 megahertz, I should see a signal coming out of the oscillator at 10.455 megahertz. That way I know the oscillator is running. So if you don't understand that, it's best to watch the Basic Receiver Theory video I have, so that you can understand that. So we're going to go and check and see if our oscillator is running. But first, before we do that, let's have a quick look here. So V2 shown here is our oscillator. It's also our mixer, but it also runs the oscillator set of coils. And there are 4 coil sets, 1 for each band. And C6 and C7 here are our tuning controls. One being the master large tuner, and the other being fine tuner or band spread. So they will, as they're switched into the given bands, tune these coils into place to run, again on this radio, high side. And I'm choosing 10 megahertz as my test frequency. You can choose another. You can choose 5 or 4, or you can do a 1 on each band if you want, but you have to make sure that you know where your injection point is, because on this radio, when you go to the top band, band number 4, the injection point changes to low side. So you're going to be 455 kilohertz below your desired frequency. So let's just check at 10. Let's see if our oscillator is running. So we'll go to the bench now. So here I'm set up to check and see if our VFO oscillator is running. I have a secondary receiver tuned to 10.455 kilohertz, or 10.455 megahertz, which is my injection frequency. So if my oscillator is running, when I tune around 10 megahertz, I should pick up a signal radiating from this radio on exactly 10.45 megahertz. So 10.455 megahertz. So we hear static, means there's no signal there. Now if we pick up a signal, the static is just going to go quiet because it's just a carrier. There's no tone, there's no audio, there's no nothing. So let's turn this up here, and I'll tune around 10 megahertz. Oh, there it is already. There we go. We see it jumped up to 48 dB. I come away from it, it drops down. So just as plain and simple as that, we know the oscillator is running, and because we can pick it up a distance away from the radio, we know it's fairly strong. So that's a pretty definitive and easy test. I would normally use a poor man's spectrum analyzer to take a look at it and look at the level output. But if you don't have such a thing, this is a very easy test that you can do to find out if your oscillator is running. And again, if you want, you can do that on each band. You can pick a target frequency on each band and make sure all 4 bands of the oscillator is running good and strong. So if your oscillator is running, it's time to move on to step 3. Step 3, trace the IF, the detector, and audio stages. So what we're going to do here is we're going to inject a 455 kilohertz signal with a tone right at the tuning capacitor. And we're going to follow that signal right through the mixer, through the IF stage, right out into the audio stage. And this is going to be somewhere the real heavy lifting gets done. This is probably where we're going to find our problem. And we're going to follow that signal through each and every stage. So let's go through that in a schematic pictorial here, and you need to stay with me. So here we have, our mixer, 2 IF tubes. This is a detector that converts the radio frequency back into audio, and a little bit of an amplifier that feeds the final amplifier stage. So what we're going to do is, here are the 2 tuning capacitors. I'm going to clip on and I'm going to inject a signal of 455 kilohertz right at that point. And we should be able to pin at each of these points, like the input of the tube here, our signal, and then listen to it on the output. It should be stronger. Then we're going to go to the next tube and we're going to pin on to the input. So if we hear a signal at that pin of the input of the next stage, we know that our IF transformer here is okay. So again, we'll listen to the output of that V3 tube, and it should even be stronger, so it's getting amplified as it goes. And when we clip on to the input of the next IF stage, if we hear our signal, again, we know that our IF transformer is okay, and when we clip onto the output, again, the signal should be stronger. And we keep doing this. We're going to go through another IF transformer, and this is where it kind of sort of starts to get interesting as we change here. We should hear our RF signal here, again stronger, but the output of this tube is not RF. We have to change our probe to audio. At this point, this converts RF into audio frequency and amplifies it a little bit. So we need to flip the switch on our probe because we're going from RF. And again, we should hear a signal going right into this amp. It's if everything's okay. So let's do that and see if we can find our issue. So we're set up. Our radio's running and warm. We have a signal generator set at 455 kilohertz. We have it modulated with a tone of 500 hertz. We have our Heathkit signal tracer here. Live. Here's the output of our signal generator. You can hear it there very clearly. So we are going to go step by step, stage through this radio until we find out where we lose the signal. So we have the mixer up here, and this is the input. And there's the sound from our signal generator. So the output is here. And you can hear it's much louder, so it's been amplified quite a bit. So we now know that stage of the radio, that's the mixer, is working. So now we're going to go on to the first IF amplifier, which is right here. We can hear the signal there. And the output, again, amplified greatly. So that stage is working well. So we go on. What we just discovered is that the mixer section is working, passing the signal through this IF transformer to the next stage. So we know that IF transformer is okay and that stage is okay. So this outputs into the next IF transformer. So this is the input to the next IF amplifier, which there it is. So we know the IF transformer is okay. And the output, again, is amplified greatly. So we know that stage of the IF transformer is okay. So we go into the last one here now. Just let me get my bearings here now. So this is going into the audio detector. So we should go in RF at one stage. And there it is there now. Okay, so we've made it all the way through to the detector. So now the output of the detector, as I had previously said, is audio. So we have to switch our probe to audio and go on this pin, and I don't have anything. Barely. Hardly any signal at all. Go back to RF, and you can hear back to audio. So we've discovered an issue. At the detector stage of this radio, there's a lack of output. I mean, you can turn this thing up so sensitive here now. You can, even just getting close to them, you can hear signal going through them until you get to that audio stage. So that's just how easy that was to find the problem. So you say, well, now what? Well, now you're not looking at the whole radio anymore. You're looking very closely at a section. So we know that there's a problem with the detector section of this radio. So now we can look at the tube. We can look at all the capacitors and resistors around the base of that tube, and it gets real simple to now track the problem. Now, I'll just make a little bit of a disclosure here. Is I've set up a problem for this demonstration. That tube is a 6SQ7, and I've put a bad 6SQ7 in that socket just to create a problem to show you how easy it is to actually pick through with a signal generator and a tracer to find the problem very, very fast. You can see if you know the radio fairly well, the pin-ins and pin-outs, you can get through this in a matter of seconds and very, very quickly hone in on the problem. So I'm just going to pause the video here now, and I'm going to put a proper tube in here, and we're going to move on, and we're going to pin out with the audio section. I've taken our bad 6SQ7 out. We're back in the RF position here. We've got lots of signal going into that tube. We switch back to audio now. And now it's controllable with the volume control now. Now we've got lots of audio, and if I use the volume control on the radio now, and I turn this one right down, I don't know if you can tell, but I've got sound now pushing through the radio, so I know I've nailed the problem. But that was pretty easy. So here we have the input here now. Let's get a little gain here to the audio section there. So that lets you quickly determine what section of your radio is giving you grief. Okay, well, I hope you enjoy that little bit of a journey. Hope that it gave you some insight as to how to narrow down where your problem in your radio is. Once you isolate a problem with a particular stage, IF or mixer or oscillator, or in the audio stage or detection stage, finding the problem after that is usually pretty easy. And it's nice because, I mean, you get signal going through your IF transformers, so you get to check those along the way. I've tried my very best to use the bare minimum amount of equipment, like having an extra bench receiver for doing the oscillator. A lot of you notice a lot of techs will have a lab receiver that they use for listening to different signals and whatnot. So having another radio for listening to the oscillator is very handy. So as we go through the journey on this channel, when we find problems like you may get audio right through, but there's nothing coming out of the speaker, and it could well be the audio output transformer. So, I mean, all of this becomes relatively easy to methodically pick through once you've narrowed down the problem to a given stage. So I hope that gets your feet wet on troubleshooting a radio. I know there's nothing more frustrating when you restore a radio, you go through and you change all the caps, and you change all the resistors, and you turn it on at the end and you don't have a radio. Well, take a big deep breath and relax, get a couple little cheap pieces of equipment out, and you can work through the problem and you can find it yourself without a great big deal or fuss or tens of thousands of dollars worth of repair equipment, or having a massive amount of knowledge. Knowledge comes with experience and time and wisdom. I mean, you can read, you can learn, but getting your hands on it, getting it done, goes a great way for that wisdom portion of the quotient. So I hope you enjoyed this video. I'm going to be doing more diagnostic type of stuff like this for the newcomers as much as I possibly can. I know probably our next module is going to be restoring another receiver using my 5-step program. So we invite you to follow along with that. If you haven't subscribed, please subscribe. I know there are 18,000 people who view this channel every month, and they come back for 1, 2, 3, 4, 5 or more videos, but they don't subscribe. So I'd love to get those folks to hit the subscribe button. They get a front row seat. They get an immediate notice when I release a new video, and join the community. So until the next one, we'll see you again.